Hi and welcome back to the general sessions. We had a slight technical difficulty because we had a special guest in our studio. We of course have Lakshman here, whom we are going to just talk to in a minute. But we also had this other special guest who came, and we had to make some space and move some cameras around and things like that. So this is the iRobot, and Lakshman is going to tell us a little more about this. He was also going to make it sing, which we will see in a minute. So Lakshman, first tell me a little about yourself. What do you do? What makes you work on these things like this and stuff?
I'm a robotic enthusiast. I'm passionate about robotics.
Okay.
So I was when I was in high school, I started developing hobbyist circuits.
Okay.
And robotics, working on small projects. So
Alright.
right now I have iRobot Create and then Robotics Studio.
You're human, right?
Yeah, of course I'm a human.
Okay, he's human, but he has a fascination for robotics, and he has been having this fascination since high school. So I believe you work with Microsoft Robotics Studio.
Yeah, exactly.
So can you just quickly show us a preview of Microsoft Robotics Studio that you have on your system?
Yeah, sure. I have a programming language called as Visual Programming Language. So
This is a programming language. This is a new programming language.
It's a new data-driven programming language.
Okay.
Think of a robot in a robotics world. Every sensor is known as, you need to pass separate data and threads to each and every sensor.
Right. So a robot basically is a bunch of sensors. For example, when I do this,
Exactly.
it's a sensor that tells me that the robot has hit something. Then there are wheels down here, which are again driven by motors and actuators, which move around. So there's a real motor-driven wheel here. There's another wheel here that spins around, and I can see that there are some other ports here and all that, to which I assume that you can connect some devices and all that. Somebody here in our crew really got disappointed looking at the robot, saying, "I expected somebody like Wall-E to come in." You know, you can make that Wall-E kind of thing right here, right? So yeah, so that's the hardware part of it. But then, how do we control that through software?
Yeah, I'll be demoing the simulation. So
Okay.
In the simulation environment, I'll be demoing the iRobot Create.
Okay.
I'll be showing you how to move the iRobot Create in simulation environment.
Okay. So this is the iRobot Create,
that's
and you have a simulated version of that, and you will move that around.
Exactly.
Go away. I mean,
So this is a VPL editor. This is IDE. So right now I'm searching for direction dialog box under services toolbox.
what's a direction dialog box?
It's actually for the 5 directions. You're moving
Okay.
the robot in 5 directions, right?
Okay.
Forward, backwards, left, and right.
Now I see why you are calling it a visual programming language. It's
Yeah,
all visual.
yeah, exactly.
You're not writing actual pieces of lines of code like we would write in Visual Studio.
Exactly, and then I'll drag and drop calculate toolbox from basic activities. It's going to
Okay.
calculate the direction of the pressed button.
Okay.
Whatever the button is pressed, it's going to calculate the direction. I'll connect the output of the direction dialog box to the input of the calculate, and then I got a connections dialog box.
Okay.
So I'll go for button release. So whenever a user press the button forward,
Okay.
so the button released and then the direction is calculated.
It's like our mouse up or mouse down or something on the PC. Here, whenever a button is created, and this one, where are these buttons really? So these buttons could be on your software program, or they could be on a remote, or they could be anywhere, right?
Yeah, exactly. Yeah.
Right.
So I'll drag and drop the switch statement because I'm using 5 inputs here. Those are the 5 directions.
Oh, switch is like your C# switch
Yeah,
case
same
thing.
thing.
Okay.
Then calculating for the button direction forward.
So you have IntelliSense and everything here.
Yeah. This is the object.
All right.
I'll add one more. That's for reverse. And that's for backwards. And this is for the right.
Okay. So you basically capturing all
And then the last thing is for the stop.
all 4 directions and a stop button.
Yeah,
All right.
Then now the main thing is I need to add a service. This service is for moving the motors, right?
Okay.
So for this is provided with a robotics framework.
Okay.
So the Microsoft Robotics Studio has a service called as generic differential drive.
Okay.
So this is a service to move the robot.
Yeah. So a differential drive would be the drive of the motor and how much thing it would work, and a generic differential drive would probably mean that A differential drive motor is basically from current position to how much difference would that motor drive, and a generic differential drive would be
it's generic. It's not only for iRobot.
It's not just for this robot. It could be used for any robot.
Any robot, yeah, exactly.
Okay.
So I'll copy and paste 5 generic differential drive services because I have 5 inputs here.
Okay. That was quick.
And connect the output of the forward.
Then just connect each of those over there.
And then I'll set the drive power. This is for the left wheel and the right wheel.
Right.
I'll say 1. 1 is the full voltage. I mean full power for left and right wheel.
Yeah. So the left and right wheels are here, and when both of them are driven, it will move forward.
Yeah, exactly. Yes.
So if one of them is done, it would move in one direction. Wonderful.
So this is for the backwards. For backwards, it's -1.
Okay.
So it moves backwards.
Yep.
Then for the left, to turn the robo left. To turn the robo left, left wheel power should be 0, and then the right wheel should be 1.
Yeah, because the left wheel stays and the right wheel goes, the robot moves left. Okay.
And then for the right, you can
do the exact opposite of that.
Exactly. Yeah.
Yeah.
Left wheel is 1, and then right wheel is 0.
Right.
Yeah. Done. And then the last thing is stop,
where everything would be 0. Let me guess.
So yeah, everything will be 0.
This is simple.
No, you have one more. No, you have one more option here. You can directly go ahead and select all stop.
All stop.
Yeah.
Okay.
It stops all the services.
Okay.
And one more thing here, you can notice on the right hand side, the property window.
Right.
With configuration, you need to set a configuration because this uses XNA framework to display the graphics.
Okay.
So I'll set the manifest. This is a manifest. Manifests are like device drivers.
Okay.
So this uses the physics engine.
Okay.
So I'll go ahead and select the iRobot create simulation manifest.
Okay, so basically in his simulation environment, because he's not actually going to make this robot move right now, he's going to test his program because he doesn't want to have a bug in his program which causes damage to this little thing over here. So he's going to try and
selected the simulation manifest here.
Okay.
So I'll go ahead and run this program. I haven't saved it.
Okay, we're running out of time, so we'll quickly have to see this, and we had promised everybody that the robot will sing, so we'll have to make the robot sing.
So right now you can see this DSS, this is decentralized system services.
Yep.
So here you can see, you can note down the HTTP address. So if you are not, you're away from the robo, you can access the robo anywhere in the world. If provided this link, you have that.
So
link.
I could be having the robot at home doing some stuff, and I could control the robot from here.
Yeah, this is the simulation environment here.
Okay.
So have the direction dialog box.
Okay.
So this is a direction dialog box.
All
this is a simulation environment. So let's go ahead and press forward. Yeah, the robot is moving forward.
So the robot is actually moving. So but it's not really moving here. It's moving in on your screen, which means that you're seeing a simulation of that thing. Yeah. So can we make it move here as well?
Yeah, we can move here as well.
Yeah, but what we'll do is, since we are running out of time and we started a little late, we'll have to cut back to the sessions. So we'll come back and do that. Now, can you quickly make it sync?
Yeah, sure.
That's a different program, and I believe you already have that program written.
That's a serial port programming.
Okay. So you're just sending it some things from the serial port, and you would actually make it sync.
Exactly.
So let's see what it sings. I hope that it's going to sing some nice Bollywood number right now.
So this is what it sings.
That looked like some language from Mars. It's actually a great hit on Mars. This is the current hit right now, the Chartbuster, and that's what our robot has learned. Thanks to Lakshman, who's been only teaching it this. Lakshman, I need this robot to play a Hindi song. Can we manage that by the next session?
Yeah, sure, we can.
Yes, we can. So we will come back to make our robot sing a Hindi number, not a Martian number, at a later time today. But then right now it's time for you to go back and join your live meeting sessions. The 5 tracks have already, the speakers are logged in and they're just going to start their sessions. There is ASP.NET 1.1 to 2.0 migration. There's MDX unplugged on the database track. Why and hows of migrating VB applications to VB.NET in the .NET World track. How to achieve desired configuration management in the infrastructure management track, and what's new in Windows Server 2008 R2 in the new technologies track. So make sure you keep participating in those quizzes for those great prizes, laptops, digital photo frames, and USB kits, and make sure you give us feedback. We'll join you back at the lunch break with some 5 interesting things from Microsoft research that you can try today.